This lecture on business software is an exploration of the transformative journey from manual record keeping to real-time access of terabytes of information. As hardware continues to advance, offering increased processing power, storage capacity, and connectivity options, software developers are empowered to create more sophisticated and resource-intensive applications to meet the growing demands of businesses. This progression enables the implementation of complex algorithms for data analysis, machine learning models for predictive analytics, and immersive user experiences through augmented reality and virtual reality technologies. In general, as hardware capabilities, for example, processing speeds, memory, network latency, scalability, and cost, improve, software gets larger. Consequently, businesses can leverage greater software capabilities to drive innovation, enhance productivity, and gain competitive edge in their respective markets. The first part of the lecture traces the historical evolution of database, business applications, and programming. This historical view is important because it helps understand the important themes of how software has changed. We will conclude with a discussion of expected future innovations in these three areas. Studying database software is crucial as it offers insights into a transformative journey from manual record keeping to real-time access of terabytes of information. Early methods of data storage and retrieval, such as paper-based systems and manual record keeping, relied on handwritten records or physical documents to store and organize information before the advent of electronic data processing. The introduction of mechanical devices, like the Hollerith tabulating machine, revolutionized data processing by automating tasks such as data tabulation and sorting using punched cards, significantly improving the efficiency and accuracy of large-scale data handling in the late 19th century. Punch cards were one of the earliest methods used for electronic data storage, developed in the late 18th century. They advanced database technology by allowing data to be stored in a structured format, using holes punched in specific locations on the card, enabling efficient data processing. The first commercial use of punch cards in electronic data processing systems dates back to the late 19th century, primarily in census tabulation and accounting applications. Electronic data processing, or EDP systems, marked the transition from manual record keeping to automated data processing using electronic devices. Emerging in the mid-20th century, they advanced database technology by introducing electronic methods for data storage, retrieval, and processing, significantly increasing efficiency and accuracy in business operations. The initial public release of EDP systems occurred in the 1950s with the introduction of early computer-based systems like UNIVAC and IBM 701, primarily used for payroll processing and inventory management. The relational database model was proposed by Edgar Codd in 1970, introducing a structured approach to organizing data into tables with rows and columns. It advanced database technology by providing a mathematical foundation for data management, emphasizing data integrity, and enabling efficient querying using relational algebra. The initial public release of the relational database model was formalized in Codd's paper, A Relational Model of Data for Large Shared Databanks, published in 1970, laying the groundwork for modern relational database management systems. Structured Query Language, or SQL, is a domain-specific language used for managing relational databases, developed by Donald Chamberlain and Raymond Boyce at IBM in the early 1970s. It advanced database technology by providing a standardized syntax for querying and manipulating data in relational databases, enabling seamless interaction with RDBMS, relational database management systems. The initial public release of SQL occurred with the implementation of the first SQL prototype by IBM in 1974, followed by the release of SQL 86 as an ANSI standard in 1986. Commercial Relational Database Management Systems, or DBMS, emerged in the late 1970s and early 1980s, offering software solutions for managing relational databases in business environments. They advanced database technology by providing scalable, efficient, and user-friendly platforms for storing, retrieving, and managing structured data, revolutionizing data management practices. The initial public release of commercial relational database management systems includes Oracle Database, originally named Oracle RDBMS in 1979, and IBM DB2 in 1983, setting the stage for the widespread adoption of relational database technology in businesses. Object relational databases combine features of both relational and object-oriented databases, aiming to address the limitations of purely relational models in handling complex data types. They advanced database technology by allowing for more flexible data modeling, supporting inheritance, encapsulation, and polymorphism, thus accommodating diverse data structures and relationships. The initial public release of object relational databases occurred in the late 1980s and early 1990s, with systems like Informix Universal Server and IBM Informix Dynamic Server introducing object relational capabilities to traditional relational databases. NoSQL databases emerged in the early 2000s as a response to the limitations of traditional relational databases in handling large volumes of unstructured and semi-structured data. They advanced database technology by providing scalable, distributed, and schema-flexible solutions suitable for modern big data applications such as web analytics, social media, and real-time data processing. The initial public release of NoSQL databases includes systems like Apache Cassandra in 2008, MongoDB in 2009, and Couchbase in 2010, offering alternatives to traditional RDBMS for specific use cases requiring high scalability and flexibility. Distributed databases enable data storage and processing across multiple nodes in a network, allowing for improved scalability, fault tolerance, and performance. They advanced database technology by facilitating distributed computing and parallel processing, supporting applications with large data sets and high transaction rates. The initial public release of distributed databases includes systems like Oracle Real Application Clusters in the late 1990s and Google's Bigtable in 2006, paving the way for distributed architectures in modern database management. Data warehousing applications emerged in the late 1980s and early 1990s, providing centralized repositories for storing and analyzing historical data from multiple sources. They advanced database technology by enabling decision support and business intelligence through integrated data analysis, reporting, and data mining capabilities. The initial public release of data warehousing applications includes systems like Teradata in 1984 and IBM InfoSphere Warehouse, formerly DB2 Data Warehouse, in the early 1990s, facilitating enterprise-wide data analysis and strategic decision-making. Current trends in database software include the following. First, in-memory databases are database management systems that primarily rely on main memory or random access memory for data storage and processing, allowing for faster data access and retrieval compared to traditional disk-based databases. Second, blockchain is a decentralized, distributed ledger technology that enables secure and transparent recording of transactions across multiple parties in a tamper-resistant manner, utilizing cryptographic techniques and consensus mechanisms. Third is AI-driven databases, which leverage artificial intelligence and machine learning algorithms to automate various database management tasks, optimize query performance, enhance data security, and provide intelligent insights and recommendations for data-driven decision-making. Business software applications encompass a broad range of computer programs designed to facilitate various tasks and processes within enterprises, including accounting, customer relationship management, and project management. Business software applications play a crucial role in streamlining operations, enhancing productivity, and enabling data-driven decision-making within organizations, ultimately contributing to their competitiveness and success. The mainframe era spanned from the 1950s to the 1970s. The 1950s saw the introduction of mainframe computers, laying the groundwork for early business data processing and computation, while the 1960s witnessed the development of basic business applications like accounting software. The 1980s and 1990s marked the rise of personal computing, with the advent of PCs and spreadsheet software, as well as the expansion of business applications such as enterprise resource planning or ERP systems and customer relationship management or CRM software. The personal computer or PC era spanned from 1980 to 2000. During the 1980s, the advent of personal computing led to the proliferation of business applications tailored for desktop computers such as spreadsheet software and early database management systems, enabling businesses to automate tasks and improve efficiency. Throughout the 1990s, there was a significant expansion in the functionality and complexity of business applications with the development of comprehensive enterprise resource planning or ERP systems integrating various business processes, including finance, manufacturing, and human resources. The Internet era occurred in the 2000s. The early 2000s witnessed the emergence of web-based business applications with platforms like Salesforce.com pioneering cloud-based CRM solutions. The proliferation of e-commerce platforms revolutionized online retail and business transactions, integrating seamlessly with enterprise software to streamline operations and enhance customer experience. Mobile and cloud computing expanded in the 2010s. The 2010s saw the rapid expansion of mobile business applications providing remote access and collaboration capabilities, and ushering in the era of mobile-first software solutions. Software migration to the cloud became prevalent, offering scalability and flexibility through the software-as-a-service model, enabling subscription-based access to business applications. Current trends in business applications include artificial intelligence and machine learning technologies, which are being increasingly incorporated into business software applications for automation, predictive analytics, and enhanced decision-making. Additionally, there is a growing exploration of blockchain for secure transactions and supply chain management, promising increased transparency and trust in business operations. Business software continues to evolve in response to changing needs and technological advancements, emphasizing innovation and adaptability for sustained growth. Understanding the history of programming in business is crucial as it provides insights into the evolution of technology, enabling businesses to make informed decisions about software development strategies, resource allocation, and technological investments. Moore's Law, which predicted the doubling of transistor count on integrated circuits approximately every 2 years, has significantly impacted programming by driving the development of more powerful and complex hardware architectures. Programmers have leveraged advancements in hardware capabilities to create increasingly sophisticated software applications, exploiting parallelism and optimizing performance to meet the demands of modern computing tasks. The following is a general evolution of business programming in chronological order. First, machine language, spanning from the late 1940s to the early 1950s, is the lowest level programming language consisting of binary code directly understood by a computer's hardware. Binary code is the representation of data in only zeros and ones. Its advantage over previous languages lies in its direct correspondence with the computer's hardware, enabling precise control and efficient execution. Examples of machine language include the instruction sets for various processor architectures like x86, ARM, and MIPS. Programmers would use machine language by writing sequences of binary instructions to perform specific tasks, such as arithmetic operations or memory manipulation. In business, machine language is used in low-level system programming for tasks like operating system development and device driver creation. However, machine language is challenging for humans to read and write due to its binary nature, leading to potential errors and inefficiencies in programming. Assembly languages, originating in the early 1950s, are low-level programming languages that use mnemonic codes to represent machine instructions. It offers a more readable and manageable alternative to machine language. Some examples of assembly languages include x86 assembly, ARM assembly, and MIPS assembly. Programmers use assembly language to write programs that interact directly with hardware, providing finer control and optimization. In business, assembly language can be used to develop system-level software such as device drivers and operating systems. However, assembly language programming requires a deep understanding of computer architecture and can be time-consuming and error-prone. High-level procedural languages, established in the late 1950s and early 1960s, are programming languages that emphasize structured programming concepts and allow programmers to work with higher-level constructs like variables and functions. They offer advantages over low-level languages by providing better code organization, reusability of code, and productivity. Examples of high-level procedural languages include Fortran, COBOL, and Pascal. Programmers would use these languages to achieve their objectives by writing procedural code using constructs like loops, conditionals, and functions. In business, high-level procedural languages are commonly used for tasks like data processing, financial calculations, and business logic implementation. However, their limitations include less efficient memory usage and lower performance compared to lower-level languages. Object-oriented programming, or OOP, languages, initiated in the 1970s, organize code around objects that encapsulate data and behavior. OOP offers advantages over previous paradigms by promoting code reusability, modularity, and scalability. Examples of OOP languages include Java, C++, and Python. Programmers use OOP languages to create modular, maintainable, and extensible software systems by defining classes, objects, and their interactions. In business, OOP languages are used to develop enterprise applications, databases, and web services. Limitations of OOP languages include potentially steep learning curves, increased complexity in certain scenarios, and performance overhead due to abstraction layers. Scripting and dynamic languages, developed in the late 1980s and gaining prominence in the 1990s, are programming languages that offer flexibility and ease of use for various tasks. They offer advantages over previous languages by providing dynamic typing, interpreted execution, and higher-level abstractions. Examples of scripting and dynamic languages include Python, Ruby, and JavaScript. Programmers use these languages to quickly prototype, automate tasks, and develop web applications. In business, scripting and dynamic languages are used for tasks such as data analysis, automation, and web development. One limitation of scripting and dynamic languages is that they may have slower execution compared to compiled languages. Current trends in business programming reflect a significant integration of AI technologies, such as ChatGPT, into various aspects of operations. Businesses are increasingly leveraging AI-driven solutions to automate routine tasks, enhance customer service through chatbots, and gain insights from vast amounts of data. ChatGPT, for instance, is being utilized for natural language processing tasks, enabling businesses to provide personalized and efficient interactions with customers through chat interfaces. Additionally, there's a growing emphasis on the adoption of cloud-native architectures, microservices, and containerization to facilitate scalability, agility, and resilience in software development. Moreover, the rising prominence of low-code and no-code platforms is democratizing software development, allowing business users to create applications without extensive coding knowledge. These trends underscore the dynamic landscape of business programming, where AI technologies like ChatGPT are reshaping workflows, improving efficiency, and driving innovation. The future of database software. As we look towards the future of databases, several major technologies are poised to shape their evolution. One prominent trend is the rise of NoSQL databases, which offer greater flexibility and scalability for handling diverse data types and massive volumes of information. Additionally, distributed database systems leveraging blockchain technology are anticipated to gain traction, providing enhanced security and transparency for data storage and transactions. Furthermore, advancements in artificial intelligence and machine learning are expected to revolutionize database management, enabling autonomous optimization, predictive analytics, and real-time decision-making capabilities. Looking ahead, the future of business applications is characterized by the convergence of various technologies to deliver more intelligent, agile, and user-centric solutions. Cloud computing will continue to dominate, enabling businesses to access scalable and cost-effective software-as-a-service applications from anywhere, anytime. Furthermore, the integration of artificial intelligence and machine learning will revolutionize business applications, empowering them with predictive analytics, natural language processing, and automation capabilities to drive insights, streamline processes, and enhance decision-making. Additionally, blockchain technology will increasingly be leveraged to ensure data security, transparency, and integrity in business applications, particularly in industries such as supply chain management, finance, and healthcare. As businesses navigate the future of programming, several major trends are poised to shape the landscape of software development. Low-code and no-code platforms are gaining momentum, democratizing app development and enabling citizen developers to create applications with minimal coding knowledge. Moreover, the adoption of DevOps practices, which emphasize collaboration, automation, and continuous integration, continuous deployment, or CI/CD, will become ubiquitous, enabling businesses to deliver software faster and more efficiently. Additionally, the emergence of serverless computing will redefine how applications are deployed and managed, abstracting away infrastructure complexities and allowing developers to focus solely on writing code to meet business requirements. I hope you found this lecture on emerging software technologies to be useful. Thanks for watching.